Hello, welcome back. Okay, so in the last lecture, we saw that the difference between two geometric means is not the geometric mean excess return. So then, how do we correctly compute the geometric mean excess return? Okay, so to see this, let's start by letting V0 denote the beginning value of our active portfolio, right? And let's let VP1, right, to be its value after 1 month or 1 period, right? So this is our active portfolio, right? Now similarly, let's let V0, right, be the beginning value of the benchmark portfolio, and we can let VB1 be its value after 1 period. All right, so this is our benchmark portfolio. Right? Now accordingly, right, we can compute the portfolio return and the benchmark return. The portfolio return, RP, right, is, as we've seen before, is given by the ratio of the ending value divided by the beginning value. Right? What about the benchmark return? Let's call that RB. Right? Well, it's given by the ratio of the ending value of the benchmark portfolio divided by its initial value. Okay? Now, remember from last lecture that we defined the compound excess return in terms of the ending values of the active and the benchmark portfolio, right? In particular, we use the ratio of the ending values, right? So now we can do the same here. Let's let Rx be the compound excess return. So now we can write 1 plus Rx, right, to be the equal to the ratio of the ending value of the portfolio return and the ending value of the benchmark return. Now, if I divide both the numerator and the denominator by V0, now what do you have? Well, you see that the numerator is, of course, this expression, right? So I can replace that by 1 plus RP, the portfolio return, right? And the denominator is the 1 plus RB, right? So now we have an expression for the excess return. The compound excess return is simply 1 plus the portfolio return divided by 1 plus the benchmark return minus 1, right? So in fact, with a little algebra, we can even show that this excess return Rx, right, can be written as the portfolio return minus the benchmark return divided by 1 plus RB, right? So this Rx here is called the compound excess return per period, right? Or the geometric excess return, right? So we notice that we defined it similar to what we did before by computing the ratio of the end of period portfolio values, but that just happened to equal to 1 plus the portfolio return divided by 1 plus the benchmark return minus 1, right? Now, notice that the compound excess return is related to the arithmetic excess return, right, which is this, right, but is not equal to the arithmetic excess return. So let's now go back to the example from last time, right, and we can compute the compound excess return for each period as we just saw, right? So what is the mean excess return over this period? Well, I'm going to, what is the first return is 1 plus 19.2%, right? That's the portfolio return divided by the benchmark return minus 2.0%, right? Times the second period, 1 plus minus 2.6% divided by 1 plus 9.7%, times the third period, 1 plus minus 15.6% divided by 1 plus minus 3.1%. Right? So that gives us the 3-month period, right? So what is the mean, geometric mean excess return? Take the 1/3 root of that, minus 1, which gives us minus 2.02%. Okay? So this is exactly what we did in the previous slide, right? To compute the compound excess return for each period. Now, in fact, right, the relationship between the compound excess return and the geometric return can be written as, right, so this is the geometric excess return. Take the 1 plus the geometric portfolio return, right, divided by the geometric benchmark return, minus 1. Right? So if I did that, let me go back and point out the numbers to you. What am I comparing? I'm comparing this. Oops. All right, so we're going to be comparing this and this. So what is that number? Well, it's 1 plus minus 0.67% divided by 1 plus 1.37% minus 1. And of course, that gives us exactly the same number, minus 2.01% or 2%. Okay? All right, so that gives us the geometric mean excess return. Okay, so far I told you that the arithmetic excess return can be misleading when evaluating past performance. Are there any situations where we should use the arithmetic average? Yes, and these tend to be the situations where we are modeling expected values of future returns, right? So as we saw previously, the arithmetic average is the unbiased estimate of the expected return of future returns, right? The expectation of future returns. So the arithmetic average or the arithmetic means provide estimates that are independent of the volatility. And that's why they are unbiased. So in the last 2 lectures, you learned that the arithmetic excess return can be misleading when evaluating performance. More accurately, we need a measure of the excess return that compares the ending values of the portfolio relative to what you would have earned with the benchmark portfolio, right? This is why we prefer the compound excess return, right, to the geometric mean difference or the arithmetic excess return, right? Neither of these latter measures give us an accurate indication of the excess wealth over multiple periods. More generally, however, you learn that the term excess return can mean many different things, right? Best practice is always disclose the specific calculation you use when reporting measures of excess returns.